Yeah. So, am I audible, guys? Please give a response in a chat window. Yeah. Thank you. Thank you. Good afternoon, Ipsita. So, today we will start with some basic questions related to the data science. Okay. So, I will start with first question. So, what is mean by features? So, guys, please answer in your chat box. What is mean by features? So first question is all about what is mean by features. And the answer is features are nothing but input variables or independent variables, right? Features but input data or variables. We are calling them as a independent variables. Independent variables. So, okay, I see some responses. So Ipsita is telling that a column represents measure of data that can be used for analysis. Measure of data, yeah. Okay. For example, name and age. So rather than that, we can frame this answer in this way. So what is mean by feature? So the features are nothing but our input data points, means the variables which are independent, which are not dependent on any other variables. So their nature should be in an independent format, and those different column name of the columns are those different variables. We are considering it as a feature. Okay. So second question is about what is mean by feature engineering. The answers in the chat window. Now we are aware about the features, right? What it is. Why do we do this feature engineering? What is the need of this feature engineering? Or what is mean by feature engineering? Yes, guys, put an answer in the chat window. What is mean by feature engineering? Sorry, guys, it's a network connectivity issue. That's why I stopped my looking at the answers. So Ipsita is telling that process raw data. So it's not about only strong, we are also doing transformation for the features also, right? So if we are stating it as a only extracting the features. So in feature engineering also there are different steps, like feature selection also there, feature extraction also there. That extraction is a one part from the feature engineering. It's not a complete thing to that complete answer to this question, that what is nothing but nothing but transforming input variables for building better model. So this is nothing but feature engineering. So we are doing different, using different techniques in this feature engineering. It's about feature selection, feature extraction, all those things are there. Now my voice is audible, guys. Is it clear or still it's breaking? Is it clear, guys? Still it's breaking. So next question is, when this train data test data and evaluation data is used, tell me the use of train data, test data, and evaluation. When this train data, test data, and Okay, for model evaluation and train data for model. So okay, trace data is for model evaluation. So you are not that much of correct about the answer. So three of the data sets are having different. So training data is used to optimize the model. Means while testing data is used to provide the final result. The final check or result. Final, we can call final check or final result. And evaluation data is used to access the model on access model on new data point. New data points during training. So in these scenarios, different scenarios, we are using this test, train, and evaluation data. Okay. So the next question is, what is the basic or prime difference between regression and classification? What is the basic difference between the regression and classification model? Yes, guys, please type your answers in a chat box. Regression is just tell me the difference in a layman terms. So how you are able to differentiate these two things, regression and classification, in terms of output. Regression used for discrete data, where classification is for numerical data. So again, it's a half answer ipsita. Discrete data, which are input data or output data. That also should be mentioned over there. Linearly separable, we proceed with regression. Yeah, in both of the cases, we are going with the linear separation only, Narsinha. So in classification also, we can separate the two classes with linearly separable fitting lines. So regression is used to predict continuous values, And classification is used to classify discrete value. Yeah, it's having more clarity, Vishwanath. Your answer is having more clarity on that. Used for discrete and continuous. Okay. Yeah, so output is our main criteria over there. What kind of output variable data type is. So in terms of functionality, we can call it as regression is used for predicting numerical or continuous output. And while the classification used for predicting discrete output. So this is the prime difference between the regression and the classification model. So based on the kind of output that data type of the output variable, we are able to say that this is the regression problem and this is the classification problem. Okay. So the next question is about how the linear regression model, I can write what is how linear regression model predicts an output. How it is predicting its output? Linear regression model. Now you are aware about in regression based model, output variable should be in a numerical or continuous format. But how it is predicting? Next question, follow-up question to that. How linear regression model predicts the output? In terms of computing, this question is in terms of computing, how it is going to predict. Any answers, guys? Yeah, Narsimha, your answer is, I can say, partially right. Regression equation, by using regression equation. So, what actually it is doing in the regression equation? That should be the answer. So, it predicts an output by multiplying and summing or adding input features along with weights and bias term. So in order to predict the output of the linear regression, so we need to convert that regression model in terms of equation. So in equation, it is just doing multiplying and adding those input variables along with its weights and biases. So this is the way to predict the output variable with the linear regression. Yeah, let's see how you have given that equation. That is right. But the interpretation in word should be like this. That equation is right, but its interpretation should be like that. Predict average using a straight line. Predict average using straight line. So it's not perfect answer. It's Ita and Vishwanath using intercepts and coefficient. Yeah, you just mentioned the terms Vishwanath. So the answer is predict output by multiplying and summing input features along with its weights and biases. So it will give the complete answer for the computation behind this linear regression. Same question, next question. It is just for the logistic. I just copy this and just change this. So give the answer, guys. How the logistic regression model predicts an output. So next question is how the logistic regression predicts the output. I don't want the answer in a more statistical way. I just want an answer in a words, layman terms with layman words, like anyone can understand from those words. So such kind of answers I am expecting for. Yes, answer to this question, how logistic regression model predicts an output. It's a logistic regression model is nothing but a classifier, right? So how the classifiers will predict the output? Yeah, binary form is the data type of that output. Lakshmi's son. The output has two categories, binary output. But I'm asking the question about related to computation. How logistic regression model predicts an output. I'm not asking about what kind of data type that logistic regression model model's output variable is having. I'm asking you how it is doing it. That 0 and 1, how it is classifying it. So Vishwanath gave me the answer that probability is equal to 1 upon 1 by e raised to e. Using sigmoid function, this classified output. Y is sum of weight and sum of weight. Yeah, so that is the correct answer, you can say. So it is based on, it's similar to our linear regression in terms of computation, but the difference is that it predicts based on the probability value. Predicts based similar to our linear regression. But predicts based on probability. Probability of any class having more. So based on that, it is computing. So this is the way that computation is happening in backend. If you are mentioning the formula, that also okay. So the output will be 0 and 1. So yeah, output is always binary class 0 and 1 for the logistic regression. And it is calculating those or differentiating those classes, class 0 and class 1, based on the probability. So the next question is, what is mean by probability? What is mean by overfitting? Overfitting. So please give me the answer for this. What is meant by overfitting? Okay, Narsimha is trained, telling that when the model is trained more than it is needed, it is called overfitting. No, that is not the case. Train error is high, test error is low. 2, 3. Yeah, we can say like that. See the just add the training time, they use high accuracy, but not work well with the testing data. So, yeah, Vishwanath, right answer. So if our model performs great, model performs great on training data set. Training data, but performs poorly on test data. Then we are calling it as a overfitting condition. That model is a overfit. It's overfitting. Okay, so that if our model is performing well with the training data and with the test data, it is not performing well. So in terms of if our trained data is having high accuracy, like for 85%, 90%, but for testing data, it is giving 60, 30, 35, 50, likewise the accuracy. Then that model is overfitting model. So the next question is, what is or what is mean by or when we use regularization? When we use regularization. When we use the regularization concept. Yeah, right answer, Vishwanath. So regularization to reduce the overfitting condition. We are using this regularization technique to reduce the overfitting condition. Can you name few regularization techniques? Adjusted loss function. If our model get a overfit, then reduce the variance. Yeah, L1, L2, no. So like lasso reach, elastic net. Okay, so these are the regularization techniques, right? Okay, fine. Nice answers, guys. Next thing is that what is meant by ensemble technique? What is by ensemble technique? Or ensemble learning? Yes, guys, answer for this. Ensemble technique is the machine learning algorithm where using multiple model data output. Okay, and we take average of at the end we take average of this model. Okay, create multiple models and combine to produce improved results. Okay, in short, predict output using multiple models. So yeah, so all of you are having the same meaning regarding the ensemble. So in ensemble techniques, what we are doing, we are just trying to build different weak learner models, and at last we are aggregating all those models to get the better accuracy or better results from that model. So we can say training multiple models with different parameters to solve the same problem, to solve same business problem. So it's like nothing but a bootstrap aggregation. We are doing that only. Yeah, yeah, no, yeah. Your answers are right. That bagging and boosting. Yeah. Those are the different techniques to of ensemble. So next question is, what is mean by A/B testing? Is A A/B testing. So what is mean by A/B testing technique? It is more related towards before our hypothesis testing. Generally, it is used. Is there is answer for this? What is meant by A/B testing technique? Yeah. So your answer is right. It is a technique to compare the two or more than two different techniques inside that which is performing better. So for that purpose, we are using this A/B testing method. Okay. It's a statistical way of comparing comparing two plus two or two plus techniques to determine which one performs better. Performs better. So if you go for a business analyst or data analyst role, then this will be a definite question for the interview. So what is meant by A/B testing and why it is used? If you are having two techniques, different techniques, you want to select one of them which is performing better. So for that purpose, we are using this. So the next question is, what is mean by baseline model? In every algorithm, we are creating baseline models. So what is mean by that? Or how you put that thing, that baseline model in a words to explain to anyone? So what is mean by baseline model? Next question is. Any answer, guys? What is mean by baseline model?
Okay, Sam is telling that it's used in multi-logic. Lowest numeric is chosen as a baseline. No, it's not a right answer. Fixed point of reference used for comparison purpose. Yeah, so that might be a somewhat relevant answer. It's a Vishwanatha. The method of uses simple summary statistic, randomness, and or machine learning to create the prediction for a data set. Yeah. So the answer to this question is this baseline model is nothing but a simple model which we are using as a reference point for comparing how well that model is performing. So that kind of models are nothing but baseline models. Simple model used as reference point for comparing well the model is performing. So the model which we built as a reference point for comparing that how the model will behave with this data, this kind of data. Such models are nothing but baseline models. Okay. Just we want to check what kind of reference point that we need to set for this kind of data. So in that case, we are using these baseline models. First, we try to build this baseline model. So the next question is, what is meant by bias? What is mean by bias? Bias in data. So what is meant by bias? All of these are very basic terminologies, but these are very, very important terminologies that you need to be clear with these terminologies, and not only clear, you also have to able to explain those terminologies. So starting point. Yeah, just breathe. That is also a right answer. So what is mean by bias? No, Vishwana, it's not a difference between predict values and actual values. Bias is a different thing.
So bias is nothing but a tendency of your data, tendency towards one class, or we can say more tendency. If your data is having more tendency towards only one class, or it is having favorism in your data towards one class, and that can affect your sampling or sampling and interpretation of that data. So if it is making any trouble to your data modeling phase or interpretation of your data, then we can say that data is biased. Okay. So the next question is, what is meant by dynamic model? What is mean by dynamic model? So what is the answer for that? What is mean by dynamic model? Yeah, Neelam. So that is the important thing. If you are understood about the concept, but you are not able to interpret that concept in a layman terms, then it's difficult to crack the interview. So it's very important to explain the terms or explain the concepts in a layman term. So if you are able to do that, then definitely you will be able to crack any kind of interviews. So that's why I am taking very basic terms or very basic terminologies related to the data science. So what is mean by dynamic model?
Yeah, so you are partially right, both of the Vishwanath and Ipsita. Yeah.
So the answer to this question is nothing but that real time. If we are having a real time data and we are just working or model building, or our model is working with the real time data, then such kind of model is nothing but our dynamic model. So answer to this question is model that is trained online. Trained online. Continuously updating fashion. So that is nothing but a dynamic model. Okay. So if we are working with the real-time data, then that model is nothing but a dynamic model. In the same way, there is a static model also there. So static model means if we are having a fixed set of data or offline kind of data, then we are calling it as a static model. Okay. The next question is, what is meant by hyperparameters? Hyperparameters. Not only time series kind of data. So if you are having the images data, continuous data that is coming from the server, like images are coming and you need to classify those images in a real time, or video is there, you need to classify the persons in that video. So all these kind of data are nothing but dynamic data, which is connected with a real time source, not only time series. There are different kind of data that we can connect in real time. Changing value of training data, testing data. Not much clarity on this answer. So I want more clarity regarding hyperparameter. So what is mean by hyperparameters? In every algorithm or in every model building, you're having hyperparameters. So how do you explain this term, that what is meant by hyperparameter in a layman term? Hyperparameters are model specific, it is parameter. Before you need to test your model and data. Parameters to resolve the issues. To resolve the issues is not a proper answer. So the hyperparameters are nothing but from which entities or which things in your model you are able to tweak your model, or you can tweak the training of that model towards achieving the better accuracy or good performance of the model. So such kind of entities or the things we are calling it as a hyperparameters. Okay. Parameters. So it's like a norm that if the norms that can that you pick during successive runs of training a model while doing multiple trials with uh, different same model. So for that, we are just making little bit change in certain things in our model while giving the inputs to the model. So those small things that we are tweaking in our successive runs of while training our model. So those are nothing but hyperparameters. So those values we are calling it as a hyperparameters. So the next question is, this is also an important question. What is mean by generalization? Okay. What is mean by generalization? Yeah, exactly right, Vishwanath. So that is the answer for the generalization. So that if we give new data also, which is unseen by the model or never came while training and all. So such a day on such data also that if that model is performing well, then that is a generalized model. Model ability to adapt properly in your previously. Yeah, right, Ipsita, right, Vishwanath. Both of you have given the right answer for this. So the answer to this model's ability to make correct predictions on new or unseen data. Unseen data as opposed to the data used to train the model. Okay. So such kind of models are nothing but generalized model. We can call those models as a generalized model. So I think it's 5:30. So today we will stop here. Few more lectures, upcoming lectures, we will go through too many terminologies, basic terminologies related to data science. And the answers will be in a very layman terms or layman words. Okay. Okay. So thank you guys. Thanks for your time. I'm stopping this session. Thank you. Thanks a lot.